Hey there and welcome to this video. Over here I'm going to be showing you how to run a torch model with infernet node. I'm basically going to bring up a infernet node that runs a torch model. Then I'm going to request it via a Web2 request, which is basically posting a job to it using the infernet node's API. And then I'm going to call it via a smart contract, and it's basically a Web3 request. So first let's bring up this node. The code for this example is going to exist on infernet-container-starter, so feel free to go there to basically get access to this code. The specific project under the project's directory here is Torch Iris, right? So Iris is the name of the model. Torch is just the framework that I'm using. So over here, let's first build the container. So make project equals Torch Iris, make build container. Let's run it. All right, good. We built the container. I mean, I built it from before, so a lot of it got cached. And now let's deploy the container. So deploy container. There we go, if I can type. Beautiful. So now we can see that the infernet node has come up and it's running that container. So one thing that we can do over here is to basically make a Web3 request. So let's actually take a look at the Anvil logs. We bring up a Anvil node with this setup so that you can test it for like Web3 purposes, right? So over here, I'm going to deploy a contract that makes a request, and then I'm going to call that contract. So infernet-container-starter, and then project Torch Iris, deploy contracts. There we go. All right, 3, 2, 1. Oh, actually, it's going to take a while to compile. Oh, never mind. It was quick. So we can see that this contract has been deployed. This is the address of our contract. And then I'm going to call that contract. So I'm going to do call contract. And then we can see that the request was sent over here. It happened super fast, but basically the infernet node picked up the request, processed it, and returned it to the contract. And over here we can see that the contract got called. For those of you who have seen the ONNX tutorial, this is identical to that. It's actually the same model, except that this time we are loading a Torch model as opposed to a ONNX model. So the code for the contracts is over here. We can actually take a look at it. Over here we make the request. Over here we receive the result of that request. One extra thing about this is that since PyTorch models expect the model itself to be in the class path, we have imported the specific model that was used to train this model, the class or like the Torch module for that model, and we have imported it in our app. And this must exist here, otherwise PyTorch will complain that the model doesn't exist in the class path. So when you are running Torch models, you got to make sure that the specific class for that model is within your class path. So just ensure that whatever Dockerized, containerized application that you run, you are importing that inside your app. Next up is to basically make a Web2 request, and we can do that via a simple curl command. So let me just find an example of this. There we go, and here it is. So over here, we can basically make a post request to /API/jobs. Here's the input data, and then it returns a ID for that task, right? And then we can check the status of this job by making a GET request to /API/jobs, and then as a query parameter, we pass an ID, and we can see that the result came back. It shows you the ID of the container, the same ID as your job, as well as the output of that entire container, which in this case, it shows you back your input that you passed in, the input shapes, and then the output data, which is the probability distribution weights for the 3 different classes of flowers, which is what that model happens to be running. So we can see that the highest weight is for the last flower. That's it. That's how you run a Torch model. You can take this example, modify it to run any torch model. And all of the code exists here, so consult these docs and codes for more information. Thanks so much for watching this video.